Hello everyone. As I promised, I'm going to record a video, but I also posted a study guide, sample quiz questions, sample exam questions. So with all that, I think you should be in a good shape for exam tomorrow. If you already studied those, you have nothing to worry about. But I thought, regardless, I post this video in case you need more preparation or kind of like refreshing your memory to make sure you know the materials for the exam tomorrow. First of all, even if you don't know much about our course and you didn't study much, if you just listen to what I'm saying right now, you still should be able to get some points for the exam tomorrow and do decent. Okay, so first of all, definitions. Okay, I'm going to write some definitions here, and I guess I just write the things that I'm going to ask, so you refer to the slide and read them. So reaction mechanism. So reaction mechanism is a step-by-step description of the bond breaking and bond making processes that occur when reagents react to form products. I want this video to be fairly short, so everyone has the time to watch it. So you can pause the video or just refer to the lectures to see the complete definitions. Okay, and when we had free radical chain mechanism of halogenation, we had 3 steps. We had initiation, we had propagation, and we had termination. And I also posted this in your study guide, so know which species are generated in each step. So for instance, here, chlorine radicals are being generated, okay, plus Cl. In the next step, we have like R alkyl plus HCl, and also we have RCl plus, again, the chlorine radical. And also in termination, we have Cl2, R2, RCl. So know these. Okay, I will ask you in the exam tomorrow. Basically, I'm just giving you the answer to the questions that I'm going to ask tomorrow. So we had cumulated, conjugated, and isolated or non-conjugated. In cumulated, we have like double bonds next to each other. In conjugated, they're alternate, and it also can be triple bonds, okay? For isolated, we have multiple bond, single bond, single bond, single bond. So they're like separated by single bonds, okay? And you can always refer to your book, which is your best resource, best friend, to see these definitions, okay? And then we have trigonal. A trigonal carbon atom is bonded to only 3 other atoms, bonded to 3 other atoms. So know the definition, okay? And then sigma bonds, this is a sigma bond. This is a sigma, okay? The only time that you have, so this is end-on overlap. The only time that you have pi bond is the time that, if I can draw it, okay, I do this. So this is like your atomic p orbital, and then you have another atomic p orbital, so you have lateral overlap of 2 p orbitals. That would be pi, okay? So know that. And also, for cis and trans isomers, cis and trans isomers in alkenes, as long as you can write the structure like this, and then you have, for instance, 2 constituents here, right? So this would be cis because your 2 constituents are one side, and if you put them on another side like this, Cl, Cl, this would be trans, Okay, and I asked you questions in the exam tomorrow about this. Okay, and remember, for alkanes and benzene, okay, we have substitution reactions. For alkenes, we have addition. Okay, remember that we had a double bond. We eliminate that and then add our atoms. You know, we basically add them to our molecule. Okay, so just remember this. Okay, in the sense of theories. And you also should be able to write names of that. A carbocation is a positively charged carbon atom bonded to 3 other atoms, depending on how many groups it attached. This positively charged carbon attaches to, we call that tertiary, or if it's attached to 2 groups and 1 hydrogen, we call that secondary, and then if it attached to just 1, we call that primary, and if it doesn't attach to any R group, we just call that, unique or methyl. Okay, this is the least stable one. This is the most stable one. So this is like how stability goes. Okay. And reaction energy diagrams. I gave you that in the exam. I already wrote the questions, so I know what I gave you. So I gave you reaction energy diagram. I tell you what is A. These are reactants. Okay. These are your products. This is your transition state. Okay, this is your activation energy. This is the energy difference between reactants and product is like enthalpy of reaction. Okay, and definition. A reaction energy diagram shows the changes in energy that occur in the course of a reaction. A transition state is a structure, I'll write it, transition state is a structure with maximum energy for a particular reaction step. Activation energy is the difference in energy between reactants and the transition state. And the activation energy determines the reaction rate. If it's like large, the reaction is slow. If it's small, right, or yeah, this reaction would be fast if this number is small. And endothermic and an exothermic reaction evolves heat, and endothermic reaction takes in heat. Okay. Equilibrium constant indicates the direction that is favored for the reaction. And if I have like this, and I gave you that in your exam, you should be able to write this formula. As long as you write this formula, you're good. This is concentration. This is mole per liter. Okay, this is moles per liter. Multiplied by d to the power of d divided by a to the power of a multiplied by b to the power of b. Okay, and then if K equilibrium, if it's bigger than 1, the reaction goes left to right. If it's less than 1, reaction goes right to left. Okay, let me see what else we got. In the sense of definitions. Okay, did I already say reaction mechanism? So reaction mechanism. Oh yeah, I think I said that. It's a step-by-step description of the bond breaking and bond making process that occur when reagents react to form products. Okay. And let me see. I think these are mostly, let me just check your exam too. Okay, so what type of reactions benzene and aromatics go through? Okay. And what is the difference between cumulated, conjugated, isolated? And what type of, how to write chlorination reactions, halogenation, bromination, and substitution reactions in general. And, how to write IUPAC names, initiation, propagation, termination, those steps you should know. And equilibrium constant. What is radioisomer? Let me go to the corresponding chapter. It's chapter 3, section 3.9 that we have these days, and 3.8. Okay, so we have radioisomers, radio specific, and radio selective. So the product of addition of unsymmetric reagents to unsymmetric alkenes are called radioisomers. Radio-specific additions produce only one radioisomer. Radio-selective additions produce mainly one radioisomer. So if it only produces one, we call that specific. If it produces multiple ones, or like one, two or more, but one of them is the main one, we call that radio-selective. And what is electrophile? Electrophiles are electron poor reactants. Let me write those two. Electrophiles and nucleophiles. Electrophiles are electron poor reactants. They seek electrons. Nucleophiles are electron rich reactants. They form bonds by donating electrons to electrophiles. And a reaction in which an electrophile, I guess I write that, electrophilic addition reaction. A reaction in which an electrophile is added to an alkene is called an electrophilic addition reaction. Okay, and let me go to chapter 4. So this is benzene. We have 6 carbons and the double bonds alternate. Okay, so this is benzene, and we studied calculate structure that basically tells us these two structures can exist almost at the same time, right? This is what it was telling us. And you can also depict benzene as this, having a circle in between. And we talk about this more when I progress with the lecture, hopefully. And we had so these are, I'm just telling you, it's your page 119, 4.6. So I tell you what is the name of this. This would be ortho dichlorobenzene. Okay, this is ortho. If I put it here, this would be meta dichlorobenzene. Okay, if we have it here, further away from each other, here, we call that para. And I was telling your friend earlier, just remember this is basically parallel. Maybe they're furthest away, they're kind of parallel, I guess. And then these are really close, ortho, or close, I don't know, however you want to remember them. Dichlorobenzene. And remember that you have multiple bonds that alternate. If I don't write these won't be benzene. They won't be aromatic compounds. And let me just like take a quick look. And make sure to know how to name compounds, you know. And if you have, like, for instance, 2 double bonds, right? So if you have double bonds in general, you have like alkene, right? If you have 2 double bonds, you have like alkadiene, right? Di means 2 double bonds. If you have 3 of them, it would be alkatriene, right? And then cycloalkanes, you know, I mean, cycloalkanes we covered in the previous exam. But in general, know all the namings too, which one is cumulated, which one is conjugated. And I thought to also emphasize on theories. And I think if you know these and then know, if you can answer questions in sample quiz that I posted, and if you can answer questions from sample exam that I posted, I think you should be all set. And good luck. And like always, you know, feel free to reach out to me anytime. I'm here. And I answer your emails most probably, you know, anytime that you send me. I'm just going to go answer your friends' emails right now. So just reach out to me.